All right, I'm going to go through this one because it was a little rough. So I feel like I've given more pep talks than ever this year. If you're not practicing these skills on a day-to-day basis, you're just setting yourself up for failure. So like a mistake here or there is fine, like on this. Like obviously I don't expect you to be perfect, but you should at least know how to do it, okay? Every day you go home with homework, and it's not like I try to be an evil person and like laugh at home at the fact that you're doing homework, although some days when you get me mad, I do. Math is learned through practice. Like if you play a sport, would you ever go out the first day, let it be a game? Like I've never played basketball a day in my life, but I'm going to start on the day of the game and I'm going to just wing it. Like you'd never do that, okay? Because you need to practice those skills as you go. Math is just like that. If you're not going to practice, if you're not going to do the homework, if you're not going to take it seriously day to day, you're not setting yourself up for success when it comes time for that test. So if I can drive nothing else home other than work on your time management, especially like I feel like especially sophomores and juniors are struggling with it a lot, okay? You can't do nothing in all classes except for one every day. You can't say, okay, I have a test in history tomorrow, so I'm going to only focus on history, and then I'm going to just do that. And then the next day I'm like, okay, I'm only going to do math. Okay, I'm only going to do science. It can't work that way. You have to do a little bit at a time each day, okay? Otherwise, putting it off is not helpful, especially with math. Like, so much of it is practice that it's insane. When it comes time for your test review, it should just be that. It should just be a quick review of the things you already know how to do. There's nothing ever on a test review that we haven't already covered. But some of you are being less successful at that than others. So when we divide using long division, first of all, you're forced to use long division this time because there's a squared term on what you're dividing by, right? We want to go through both of them and see, are they in decreasing degree order, is anything missing? And from the dividend, the thing that goes underneath, there's nothing, right? It's in order, there's nothing missing. But what's true about my divisor? It's missing the 0x. So I have to include that. So you're testing that out for both what you're dividing into and what you're dividing by. So this would be x squared plus 0x minus 3. And then I do first to first. So what would I have to multiply x squared by to get to x to the fourth? X squared. And it goes to times all three terms. So x to the fourth plus 0x to the third minus 3x squared. And then you... Yeah. Otherwise, you won't have anything to combine with your x to the third, right? If you don't add this in, you end up putting this here and then combining. You're leaving a space?
I mean, I put 0x, yeah.
Yeah.
Put it in. I just didn't put it on the outside.
So you're going to know to do it every single part along the way, which just makes it harder. Yeah. And then I'm going to change my signs. And then this cancels. I get negative 2x to the third plus 4x squared. Bring down the 2x. And repeat that process. So what would I have to multiply x squared by to get to negative 2x to the third? Negative 2x. And then that gets multiplied by all three terms on the outside. Negative 2x to the third plus 0x squared plus 6x. Change your signs. These cancel. 4x squared minus 4x. Bring down the last term, which is a minus 8. And then what do I have to multiply x squared by to get to 4x? Positive 4. Multiply that times all three in the front. 4x squared plus 0x minus 12. Change your signs. Cancels. Negative 4x plus 4. So several of you got to that point. X squared minus 2x plus 4 plus a negative 4x plus 4 over x squared minus 3. Okay? But I said it yesterday and I'll say it again. If the leading term on what your remainder is negative, you have to pull it out front. When I pull out a negative here, it affects both of the terms that are in my numerator, which is where a lot of you messed it up. Okay? So the quotient is x squared minus 2x plus 4 minus both the signs change up here. So it should be 4x minus 4 in the numerator. Esty. No, if you multiply by, think about like negative 1 is a negative 1 over a positive 1, right? So you only need 1 to change. So a lot of you got close, but just make sure you know that last step, okay? And the second one, I would say mostly did pretty good. So synthetic division, the remainder theorem says use synthetic division, and then whatever you get for the remainder is the same thing you would get if it said evaluate the function. So f of 2 is 0 here. If you didn't get it right, it was probably a silly mistake, so just make sure you're careful. All right, number 3 says using f of x equals x to the third plus 3x squared minus 4x minus 12. Find A, all the possible roots, and then B, all the actual roots. I would say that probably one of the hardest parts on this section is that there's been so many different kinds of instructions that it's sometimes hard to know what to do from the get-go. Sometimes it's not as straightforward as that, right? So even in the homework, there's a question that just said find the possible roots, and y'all started figuring out all the roots, okay? Pay attention to directions. Read them slow and careful so that you don't mess it up and then have to redo it. So when it's looking for the possible roots, it's just looking for the factors of the last over the first, right? So plus and minus last over first. This has to be in decreasing degree order in order for that to happen. It is, right? Factors of the first would be 1. Factors of the last, which would be 12, is 1 and 12, 2 and 6, 3 and 4. So I put all the factors of the last over all the factors of the first. Yep.
It doesn't matter if the numbers.
No, because we're doing plus and minus to all of them. That positive 1 and negative 1 are both factors, so it doesn't matter. Yeah. So then I would do 1, 2, 3, 4, 6, and 12 all over. The only factor this time is 1. But again, if this was like a number 3 on the front, I'd have to put all of those over 1, and then I'd have to put all those over 3 and simplify them out, okay? So now I get that my possibles are just plus and minus 1, 2, 3, 4, 6, and 12, and you can list them like that as long as they're simplified. Then B says find the actual roots. So I would say if you're beginning this and there's a ton of roots and you want to like try to use some tools to help you figure it out, the easiest one is Descartes' rule. So like if you just look at your initial function to figure out how many positive possible roots there are, how many sign changes are there? There's only one sign change, which means what? There has to be one positive root. So I would stick to my positives first, okay? Because when I plug in a negative, I might get that there's 2 or 0 negatives. And because that 0 is an option, it means that you could try all of your negatives and not be successful. So I, because it's 1, would start with the positive roots and skip the negatives. So I'll put 1 on the outside, and I'll go 1, 2, 3, 4, 6, and oh, I'm listening to possibles. Just kidding. 1, 3, negative 4, negative 12. Bring down the 1, 1, 4, 4, 0, 0. That one doesn't work. So instead of going to negative 1, I'm going to 2. 1, 3, negative 4, negative 12. And I should have said this, but you need to make sure that these all have, right? There's no missing spots before you start your synthetic. There's not, so we didn't have to worry about it, but make sure you check that. 10, 6, 12. So 2 works. 2 is one of my roots. So then I take my decreased degree function, which is x squared plus 5x plus 6, and I get x plus 2 and x plus 3, which means my other roots are negative 2 and negative 3. So 2, negative 2, negative 3, those are my actual roots. So this was A, the possible roots. This is B, the actual roots. Sarah.
How could you use like the bounds on this one?
So the bounds would be, so a perfect example of bounds would be if you look at 1, this was negative 12, right? So let's just say when I did 1, when I looked for 1, all the bottom numbers were positive or 0. So there's no negatives there. Say that negative 12 was a positive 12. I would know 1 is as high as it goes. Don't go any higher. If I plug in a negative on the outside and it alternates, I would know that's as low it goes. Don't go any lower. So that's how you can use it to help you. Again, I'm not going to ask you for, there is a question on Descartes' rule, like tell me how many positive and negative roots there are, but there's nothing specifically on upper bound or lower bound. You can just use it. Okay. And then as far as the question goes, I was trying to explain this to somebody today, like if I gave you a straight out question, maybe not as, I think this one's pretty easy, but maybe not as easy as this, but one with a lot of roots, you would spend half of your test time doing your possible roots, or you could, right? Especially if you accidentally miss one. For me, that's not an effective way to use the test time. So this kind of question will come on the calculator portion, in which you're going to list me the possible roots. You're going to use your graphing calculator to find the one and only root that's a whole number that you'll be able to find, or a terminated decimal like 1/2 that you'll be able to find. Then you'll reduce it a degree, and then you'll find the other roots, which the other roots won't all be whole numbers. So it won't be as easy as this, but you will have your graphing calculator. Does that make sense?
So for this type of question,
You're going to have your calculator.
Okay.
Yep.
So, but are there going to be like any other simpler questions that we're going to have to use, like, that we're not going to be able to use our calculator?
Yep.
Okay.
Yeah, so there's 2 questions with the calculator, and everything else is without. when I go through the review, I'll indicate like which ones are which. Sarah.
And on the calculator, would you just graph it?
So you would graph it. You would find the one root you can identify easily because there's going to be one you can identify easily, and then the others are going to be like decimals that you can't use because you can't round them.
Yeah.
And then you'll use you'll use synthetic division with that root on the outside. You'll decrease it a degree, and then you're going to have to solve that by either factoring or using the quadratic formula.
How do you find a root on, like, what's a root on a graph?
An X intercept. Yep. So there's an example in the review notes. Hopefully we'll get to today. If not, it will be on the video. So you can, and then that's how you would do it. Find the whole number, and then use the synthetic division, reduce it a degree, so now it's squared. You'll either be able to factor it, or you'll have to use the quadratic. Okay. Esty.
Can we go over the homework one?
Sure. Give me like your question.
Okay, it's not long.
Okay, so this was 5 from the homework. So it said, given f of x equals this, right? This is equal to f of x. And one of the factors is given. In this case, it's 2x minus 1. Find the additional factors, right? Then do complete factorization, then give all the roots, right? That was the process.
Yeah.
So if this is a root, then I would know I have two choices, really. I could take 1/2 and put it on the outside, do synthetic division, or I can use long division, either way. So let's try, because we haven't done it with the fractions, let's try the synthetic division. So 1/2 goes on the outside, and then I would list my coefficients, which are 2, -1, -6, and 3, because there's nothing missing. Bring them to 2. 2 times 1/2 is 1. This is 0. This is 0. This is -6. 1/2 of -6 is -3, and that's 0. So that's verifying that it's a root. That it's a root, right? Then I want to take my remaining quotient, which is this, and I've got to find the factors of that. So even though 2 and 6 are not perfect squares, well, first of all, I would take out a 2, and then I get x squared minus 3. Even though 3 is not a perfect square, I can still write this as a factor. I can do the difference of 2 squares with this. I just have to keep it as square root 3. So this can actually be written as x plus root 3 and x minus root 3. And then 2 by itself can never be a root. So I ignored that 2, because if this was equal to 0, I would have divided by 2. It would have gone away. Which means that these are my initial or remaining factors. So that would be the answer to, I think it's part A, right? A, remaining factors. Factors are in parentheses, right? So remember, you can make sure you can distinguish between the words factors and the words roots or zeros, right? Factors mean put it in the parentheses after x. Then it asks for the complete factorization, which is not only these two, but also the one that they gave you at the top, which is 2x minus 1. That's the complete factorization. Then it said find the zeros. So I'm going to solve each of these, and those are your zeros. If you don't, if you forget how to factor this part, if I'm not good at going from here to here, then I can, and I'm just looking for the roots, I can actually take this, set it equal to 0, and do x squared equals 3, and then x equals plus and minus the square root of 3. That's how I can get my roots. And then to get my factors, remember the end of 2, 2, we just do x, opposite sign, follow the root. So it would be x minus root 3 and x plus root 3. Questions on those? Any other questions from the homework? Madison. Is it the last one? Okay, so I'll walk you through the process. Remember, you can go back in and check your answers now because everybody's answers are different. But I'll tell you right now, it's going to be a cubic on your, so that one you had to find 2 roots. And you can find them both from your calculator, so I'll show you what that looks like. Give me numbers.
4x to the 4th. Do I tell you the numbers I added into it too? And 0x.
Give me the initial one first, and then we'll do that, yeah.
4x to the 4th minus 99x to the 2nd minus 65x plus 300.
So even the one, even though I am giving you a calculator, which would make it a little bit easier on this to have big numbers like that, but I don't need you to list 35 possible roots on your test. So as long as you know how to do it, they're not going to be as big as that, okay? God bless you. Because technically it would be plus and minus 1 and 300, 2 and 150, 3 and 100, 4, right? 4 and 75, yep, because that would be quarters, right? 5, I'm running out of space, and 60, 10 and 30. Did I skip 6? Oh, yeah, 6. Oh, no, not 6. No. Yeah, 6 and 50. 12 and 15. Am I missing anything else? I think that might be it.
15 and 20.
Say again? Oh, no, 15 and 20. Okay, so all of those, wait, so 12 is 35, not 15. Yeah. All of those would be numerators, right? And then the denominator, so all of those would then have to go over 1, over 2, and over 4. So I'm not going to give you that many possible roots, but just so that you know the process, obviously you are going to have to do that, okay? They'll be smaller numbers. So then once I did that, let's go through the processes as though this was on your test. You'll get asked for the possible roots, and then you're going to have your graphing utility. You're going to graph that function. So if I type that into my y equals, which I think I already have it in here. So if I type that into my y equals, and then I hit graph, and my window at the beginning was really ugly. It was like hard to see where it crossed through the zeros, okay? You are going to have, first of all, the difference between this and your test is on the test, it's a cubic, and you only have to find one root to reduce it. You're only going to be able to find one whole number root, okay? Or one nice pretty root. For this one, you actually could find 2 whole number roots. So if you look at where it crosses through the x-axis, there's a point here that's a whole number, and there's a point here that's a whole number. So that was, what is that, 1, 2, 3, that's -4. And 1, 2, 3, 4, +5. So again, on your test, it's going to be cubic. You only need one of those. Does that make sense? And then you'll find the other 2. But for purposes of this example, I'm going to continue to work through it, okay? So, okay, so we got the 2 roots. So again, on your test, you're only going to need 1, but then I take that root, I'm going to put it to the outside of my synthetic division. So let's say I take the -4, I put the -4 on the outside. Now you got to worry about those zeros, right? So Maddie, you were listing them before. It'd be 0x to the 3rd here. So I'd get 4, 0, -99, -65, and 300. So they're big numbers, but you have a calculator in front of you on your test. Use it. So this would be -16, -16, +64, 35, -140, -205. Is that right? Nope, that's not right. I just said to use your calculator and then I didn't myself. So it's -35. That's +140. 140 minus 65. 75, that makes more sense. This is -300, and then that's how I would have verified that that one's a 0, okay? On your test, that would bring it to a quadratic, and then from there you'd be able to factor or use the quadratic formula. Let's just say this happens, right? Not only do I use 4 there, but then I can use 5, and I would use it with these numbers. So I've already reduced a degree. If a factor is a factor of the original, it's also a factor of its factors, if that makes sense. So this is 4, this is 20, this is 4, this is 20, this is -15, this is -75. Now I've got this function. So you wouldn't have to do just that last step on your test, but everything else is the same. And I could either try to factor that or use my quadratic. So 4 times -15 is -60. Are there factors of -60 that sum to +4? So +10, -6, plug those in. And then factor by grouping. So 2x, -3, 2x minus 3, 2x plus 5. And my other roots are 3/2, -5/2. So then all of the roots are the 2 that we found from the graph, which are -4, +5, -5/2, and +3/2. So the process is similar to what's on your test minus the second root. Everything else is the same. Okay, you're going to have to graph it. You're going to have to find one root from your graph, right? That should be easily identifiable, like a whole number or a fraction like 1/2 or 3/4 or something like that you can identify. Then you're going to put that one on the outside, use synthetic division, show that that's a 0, reducing it at a degree, and then what's left can either be factored Or you'll use the quadratic formula, which we're going to review in a minute. Riley.
Can you plug them into just the equation that you get from doing the synthetic division, like can you plug and like factor out like the 10x and the 6x?
The 10x and the 6x.
Like 4x squared plus 10x and then negative 6x minus 15, that equation just comes from
That came from, so by reducing it a degree, you bring it to a cubic function, right? But that cubic function wasn't factorable. So I reduce it another degree, and to do that, I use the one that's reduced. Otherwise, if I go back to the fourth and I reduce it, I'm still stuck at the third. So if you have two roots, and it's a fourth, let's say, right? The first root reduces it to a cubic function. Then you have to use the cubic function to reduce it the second time. Does that make sense? Okay.
If you were to take a reduced down by a power and you were to plug it into the calculator, you should get the same.
You'll get one less root.
Okay.
So you'll get the other three roots. Yep, if you do it correctly. It's just that I'll warn you right now, they're not going to be,
No, I know, but just
like on your test, like, I mean, I gave you one nice, pretty one, so you could use that with the synthetic, and then the other ones are going to be random fractions that you won't know based on its decimal, or they're going to be irrational, meaning a square root, which there's no way for you to convert that. So you'll have to still show the work anyways, but yes, technically that works. It just would eliminate the root that you eliminated. So like if I regraph this, -4 won't be a 0. If I regraph this, -4 or 5 won't be a 0.
but they'll all be
But the other two will be.
anyway.
Okay, so in comparison with the one that is like this on your test, I'll say there's two differences. One is yours is only raised to the cube root on your test, so you're only going to have to find one real root to reduce it. Okay, two, the numbers are a little bit smaller than this, but you are still going to have to find possible roots. You still have to use discards, and then you still have to find the root using the graphing calculator. Okay, so if I do the factors, this time I've got 1, 4, and then 2 and 2. So this time I'm going to have additional factors other than just all of them over 1. 90 is 1 and 90, 2 and 45, 3 and 30, 4 and 15, 5 and 18, 6 and 15. No, it's not 4 and 15. Just kidding. Four doesn't go into it. That would help. Okay. 7 doesn't go into it. 8 doesn't go into it. 9 and 10 are the last ones. So if I'm doing the possible roots, it's plus and minus all those roots over 1. So 1, 2, 3, 5, 6, 9, 10, 15, 18, 30, 45, and 90. All of them over 1. And then all of them over 2. So if I put 1 over 2, I get 1/2. If I put 2 over 2, it's 1 and I already have it. 3 over 2 would be 3/2. 5 over 2. 6 over 2 is 3. I already have it. 9 over 4. No, sorry, 9 over 2. 10 over 2 is 5. I already have it. 15 over 2. 18 over 2 is 9. I already have it. 30 over 2. I already have. 45 over 2. And then 90 over 2 I already have. Then I would say, okay, put them all over 4. So that brings in 1/4. 2/4 is 1/2. I already have it. 3/4. 5/4. 6/4 is 3/2, and I already have it. 9/4. 10/4 is 5/2, and I already have it. 15/4. 18/4 is 9/2, I already have it. 30/4 I already have. 45/4. And then 90/4 I already have it. Nope, 90/4. Which would be 45/2. Oh, I do already have it. I thought I already had it. So those are all my possibles. They're not going to be that many. I don't want you to spend 15 minutes on your test listing out. It's not effective test time, right? Okay, but there could be a bank that's like half that size. You will see more than just your regular 3 possible roots, okay? And you would just list them all out. And then instead of, again, using like a test to spend a half hour trying to find a possible root, for me, that's not what I want you to spend. You won't finish the rest of the stuff, right? Because especially if you miss it the first time around, you're screwed. So what you'll do is you'll use your graphing calculator to find the whole numbers ones, or the 0.5s, that kind of thing. So if I did that, I'm going to show you, walk through that process. So, all right, so if I type that function in, right, 4x to the 4th minus 30 43x squared minus 9x plus 90, and then I hit graph. Okay, and if you look at this graph, my window's all funky, but if I did negative 10, 10, if I look at that graph, I'm going to see where it crosses through my x-axis, okay? You are going to have, because it's only raised to the third power on your test, you're only going to see one good root. And then the other ones are going to be decimals that can't be converted, which means you would have to round them. And the question directions literally says there is to be no rounding. You're supposed to leave these roots exact. So what you'll do is you'll grab your nice rounded ones and you'll use those with the synthetic division. So if I look at this graph, there is one crossing through at -2. And there's one crossing through at 3, which I can also get from my table, second table. You can see -2 is 0 and 3 is 0. So that's where my roots are. -2 and 3. Again, on your test, you're only going to see one because it will be an x to the third. Okay, so you get one of these. But I'm going to go through these motions just because they're the same concept. It's just however many times you're doing it is going to be less. So I'll take the -2 first. I'll put the -2 on the outside, and then I'll do 4. There's no x to the third term, so I'm going to add in a 0. -43, 9, and 90. Bring this down. 4, -8, -8, 16. And you have a calculator. Wait, is that right? Nope. Yep. Then multiply it. This is 54. This is 45, -90, and 0. So that's reduced 1 degree. On your test, that would be it. You reduce it 1 degree, and then it would become quadratic, and then you would factor it and solve it. This is still cubic, okay? And it's not in, I can't factor that by grouping. So I would have to use in another root. That's where that 3 is going to come in handy. So I put the 3 on the outside, and I use the reduced function, because if something is a root of the initial one, it's also a root of the reduced one. And then I would do it again. So 4, 12, 4, 12, 15, -15, -45. So now I've reduced it to the point that it is a quadratic. And then I would see if I could factor it. So 4 times -15 is -60. Factors of -60 that sum to -4 are +10 and -6. And then add those in place of the 4x. And factor by grouping. Take out a 2x here, and I get 2x plus 5. And then from here, take out a -3, 2x plus 5. So my additional roots are -5 halves, 3 halves, and then the 2 that they gave me from my graph, which is 3 and -2, so all 4 of those. So the process is only elongated here. Obviously on your test, it's a cubic one. You're only going to find one from your graph. You're going to use synthetic division to reduce it one more, and you get to the squared, and then that could be either factored or use the quadratic equation, okay, or quadratic formula. Any other questions from your homework? Yep.
I had one division.
Okay. The good news is you guys all have the same class, so it's good for you that you asked, because nobody else has asked that today, and I'm sure everybody else is confused. So 5x to the 5th, I'm missing a 0x to the 4th, I'm missing a 0x to the 3rd, I'm missing a 0x to the 2nd, I'm missing a 0x, and the +3 is the last one. And then on the outside, I have x to the 3rd, I'm missing a 0x to the 2nd, I'm missing a 0x, and then I have a -1. Did you get there? Yeah. Okay. So then first to first. So what would I have to multiply x to the 3rd by to get to x to the 5th? Good. And then I multiply it times all of them, which means x to the 5th, but then 0x to the 4th, 0x to the 3rd, 0x to the 2nd. Nope. -1. Sorry, that's the only one that's not 0. -1x to the 2nd, or -x to the 2nd. Change my signs. This doesn't matter. Plus here. These cancel, and all I get from that range is x squared, right? The only thing left is 3. So I could bring down that 0x, because that's like the natural thing to do, right? Plug 0x. And then I could bring down that 3. And the way you know to stop is that this exponent has gotten smaller than the one on the outside. So I'd actually have to do like an x to the -1 on the top to get it to go smaller, which is where we stop. So the x squared is the only part of my coefficient. And then the x squared plus 3 over x to the third minus 1 would be my remainder. So it's funky because you're having so many zeros, but the process is the same. Okay. Like one of your roots was 2x minus 1, something like that? What's that? It depended on your, yeah. What did they give you?
You gave me
Yeah, 2x minus 1 is your factor, right? And then you get to here. So when you...
Like I got these parts all right. I just didn't know what the remaining
when you
factor
get
was.
here, when you take 1/2 and you put it on the outside of your synthetic division and you get it down to 0 and you end up here, you have to factor that.
Okay.
So factors are the sets of parentheses.
Yeah.
So you could take out a 2, x squared minus 7, and then even though 7 is not a perfect square, you can actually say this is x plus root 7 and x minus root 7. So these two are the remaining factors.
Okay.
In the parentheses. So factors means in parentheses. The complete factorization are those two. That's a root. And the first one they give you.
Yeah.
And then the roots, you solve those. Yeah.
Okay. Thank you.
So just, and that's what's going to get people is what's the vocab terms there. So factors are in parentheses. Roots are solved.
Yeah.
Like since it's the 2 in front of there.
Yeah.
Have to put
That's not part of your factors.
just the parentheses.
Yeah. It would be if that was set equal to 0, you divide everything by 2 and it would go away.
Oh, okay.
Yeah. So the first thing I'm going to do is, we've got about like 22 minutes. I'm going to go through concepts first, and then to work out specific examples, I'll either go back to them on the video, or if we have time today in class, I'll go back to them. Okay, but there's some things that we've seen so many times, like these first ones are on your quiz review. So if you need to see them there too, they're also there. There was like 10 versions of that quiz. We talked about it yesterday, that within this class, you could find another practice quiz, right? From finding somebody that had a different version. If you have friends in other classes, feel free to ask them for them, okay? Just ask for somebody that has all the right answers, because it'll make your life easier, okay? Or piece them together. But there's plenty of practice you can get for 2-1 to 2-2. So 2-1 was your quadratics, right? So we started with standard form and converting it, in quadratic form and converting it to standard form. So you had something like this, and this is complete the square. You group together ax squared and bx. If a is not 1, like in this case, you factor that out. So I would have to take out a -3 in this case. Once I do that, I take whatever b is, divide it by 2 and square it. And that's what I'm going to add to inside the parentheses. And I would normally just subtract that from outside the parentheses. But if you've taken out an a, like in this case, we're going to have to take out an a, you have to multiply that a times what you'd be subtracting from the outside first, and then combine it with that term. Once you do that, you force it into a perfect square trinomial. So you factor doing the square root of the first, the square root of the last, the sign from the middle, put it in parentheses, square it, and then the k would be on the outside. Let's say you chose that method, right? And then it asks you for the vertex. It comes straight out of so that it would now be in y equals ax minus h squared plus k. So once you get past step 5, that's what it should look like. Then your hk comes directly out of your equation. You just change the sign on what it's after the x for your h. The axis of symmetry is x equals h. Don't forget your x equals. A lot of you lost points on your test because of that. The domain for parabolas is what? Negative infinity to positive infinity. I just give you an answer to your test. You're welcome. Okay? It's going to ask it on a parabola. That's your answer. And then the range, if my parabola opens upward, is k to positive infinity. And if it opens downward, it's negative infinity to k. How do I know if it opens upward or downward? Good. If the a is positive, it opens upward. If the a is negative, it opens downward. It could ask you for the y-intercepts. In this case, my x is 0, and then I would solve for y. The x-intercepts in this case, I'm going to say that y is 0 and solve for x. In this format, that means subtract the k, divide by a, and use the even root property to get the x-intercepts. So you don't have to factor in this format. And then the max and the min, you're going to tell me which one it has. Does it have a max or does it have a min, right? If it opens upward, it has a minimum, and the minimum value is just k. So while your intercepts are points, coordinate points, your max and min is just a number. If it opens downward, it has a max, and that max is also K. So you use the H for the vertex and the axis of symmetry. You use the K for the vertex, the range, and the max or min. Because you use them again, please be very, very careful finding them. Questions on any of that? So again, I'll go back and work out this example, but for now, we've seen it a bunch of times, hopefully. This is review. But that would be your complete the square component. Okay, so now we're going to walk through the complete the square of this example. So the first thing that we need to do is group together the negative 3x squared and the 5x, and then bump a space for what I have to fill in, bump that 2 to the outside. So then I take what's in front of the x squared if it's not a 1, which in this case obviously it's not, take it out, put it on the front of my parentheses. So in doing so, I'm dividing both this term and this term by it, which makes this a negative 5/3 x. Leave that space because we still have to fill it in. So then I take the middle term, which is that negative 5/3. I'm going to ignore the sign because at the end we square this, so it doesn't matter. 5/3 divided by 2, which is the same thing as 5/3 times a half. And I get 5/6. And then square that, and I get 25 over 36. And that's what I'm going to add inside the parentheses. And normally I would subtract it from outside the parentheses to balance out this equation, but because we took something out, I have to multiply it by that first. So negative 3, well, negative and negative makes that positive. 3 goes into 36 12 times. So I'm going to be adding 25 over 12 to that 2. So I'm going to rewrite this. This is negative 3 parentheses x squared minus 5/3 x plus 25 over 36. And then that 2 is positive. This is a positive 24 over 12 plus 25 over 12. So positive 49/12. This is still all equal to f of x. So then I've made this a perfect square trinomial. That was the goal here, which means I can now factor it. So I get f of x equals negative 3 on the front, square root the first term, which is x, square root the last term, which is 5/6. Take the sign from the middle term, which is negative, put it in the parentheses, square it, plus 49/12. So there's my equation in standard form. And then from there, you can answer all of those questions, such as the vertex being HK, which is 5/6, because you changed the sign here, and 49/12. For my intercepts, I would set it equal to 0 and solve by subtracting the 49 over 12, dividing by negative 3, and then doing the even root property on there. For the y-intercept, I will plug 0 in for x, and then simplify from there. For the domain, all real numbers, the range, because this opens downward, would be negative infinity up to that 49/12. And then for my intercepts, I would, I'm sorry, not for the intercepts, for the max or min, this is facing down, so there would be a maximum of the y-coordinate of your vertex, which is that 49 over 12. And then graph it from there. The second method to solving or to graphing if it's in quadratic is to keep it in quadratic so we don't have to complete the square. And then we find the vertex by doing negative b over 2a for the h. And then we plug the h back in to get the k, we plug the h back into the x and then solve for y. X intercepts this time, still same thing. The y will be 0, except this time you'll probably factor. And then the y-intercept, also the same, except that's the fastest thing you can get because your x's are going to cancel and it's just 2 in this case. And then for both of those, you need to make sure you know how to graph it. So I'd graph my vertex, I graph my points that I'm given, and if there's additional points I need, I plug them in. I have to have the vertex and 1 point on either side of your vertex to graph, but that's it. You only need 3. For this, I need my standard form. I make the vertex, the h, the k, the point, the x, the y. I take them and plug them in. So 5 equals a x minus h squared plus k, which is a negative 4. And then follow your order of operations. A lot of silly mistakes were made here on your quiz. 1, people forgot the squared and kept that as 9. 2, once they got to this point, oddly enough, they did 81 minus 4, which is not order of operations. So don't do that, okay? You would add the 4, and I get 9 equals a times 81, and then I would divide both sides by 81. And I'd get a equals 9 over 81, or 1/9. And then you would take that and the h and the k and plug it back in. So the y stays as y, the a is 1/9, the x stays as x, minus 3 squared minus 4. And again, don't forget the squared. That's another common mistake that was made on your quiz. Questions on that one? Easy stuff, right? Just don't make a silly mistake. Okay, so now we're going to work through the second way in which you can use a function to graph. So this parabola, which we know it to be, I would find my vertex by doing negative b over 2a. So the a is negative 3 and the b is positive 5, which makes my vertex negative b over 2 times negative 3, sorry, negative a, negative 5, which is negative 5 over negative 6, or 5/6. So that's the h coordinate of your vertex. Then I'm going to take and plug that back in. To get the y. So negative 3, 25 over 36, plus 25 over 6, plus 2. 3 goes into 36 12 times, so that's negative 25/12. Change this by multiplying by 2, so 50/12. Put this over 1. This now has to get over 12. Multiply by 12 plus 24/12. And then this is negative or positive 25/12 plus 24/12, which is 49/12. And there's the y coordinate of your vertex, which matches what we did on the first one because this is the same example. So now to get the x intercepts, I would say 0 equals negative 3x squared plus 5x plus 2. And then I want to factor that. So I'm going to multiply negative 3 times 2. I get negative 6. Factors of negative 6 that sum to positive 5, which would be 6 and negative 1. And then plug those in the place of that middle term. And factor by grouping. So I can take out a negative 3x, and I get x minus 2. Take out a negative 1, x minus 2. X minus 2, and negative 3x minus 1 tells me that my zeros, or my intercepts here, would be 2. Positive 1/3 divided, or positive 1 divided by negative 3 is negative 1/3. So when I write these, it would be 2, 0, and negative 1/3, 0. And then from this format, it's even easier to find the y-intercept because this would become 0, this would become 0, and my y-intercept would be 0, 2. So I've got my x-intercepts here, my y-intercepts here, my vertex here. And then all the other information is the same as before, domain and range, max and min, that kind of stuff. Okay, then we got to 2, still on your quiz, and it started with n behavior. So these are polynomial functions of higher degree. The n behavior is what the arrows look like on the left and the right, and they're determined by the degree, okay, of your polynomial. So the one with the highest exponent. So if I'm looking at a sub ax to the n power, the first thing you want to do with these is rearrange them in order from highest to lowest, okay? Because some people, and I don't know if it was this class, some people forgot to do that. Like the x to the fourth was the last one. They didn't pump it to the first, and then they answered the questions wrong. So if the n is even, so if the highest exponent is even, and the a, or the number on the front, is positive, then both point up. If the a on the front is negative, then they are both down.
This is my favorite one.
Is it?
I do the.
I'm gonna record Mr. Saxon doing that one day, and then I'll put little gifs in your notes, so it looks like him dancing. Okay, so if the highest exponent is odd, and it's positive in the front of the a, then it falls left, rises right. And if it's a negative a, it rises left and falls right. This follows your normal quadratic and your normal cubic. So like if you forget, think about what a standard parabola looks like. If it's positive, it goes up. If it's negative, it goes down. And a standard x to the third, if it's positive, it goes up, right, down, left. And then if it's negative, it flips it. So hopefully you can remember that stuff too. Then you're going to find the zeros. So the zeros, I would set my equation equal to 0 and then solve, and you list these. Like x equals blank, 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 blank. Okay? You don't give these in point format. The multiplicity is the number of times these occur. If it's got an even multiplicity, what does that tell you? No, like on your root. It bounces, right? And if it's odd?
It crosses.
Good. So even, bounces, odd, crosses through. So in one grouping, here's your function, find your end behavior, your zeros, multiplicity, your y-intercept, and then graph it. You add this because this is what we added on to 2, right? Given the zeros. So if I told you to find the function with the given zeros, and they are -2, 2 plus root 3, and 2 minus root 3. Okay, I'm going to jump right to one that's a little bit more complicated. So I do x, change the sign. So x plus 3, this is a positive on the front here, so this is x minus 2 plus root 3. This is also positive, so it's still x. Oh, but there's an extra parentheses there, hang on. X minus 2 minus root 3. And then the x plus 3 is going to stay the same. This changes to x minus 2 minus root 3. This, okay, then it's x minus 2 plus root 3. And then again, I would start with the conjugates because the roots are going to cancel out. It makes it a little bit easier for you. So first one times each one is x squared minus 2x plus x root 3. And then do the second one times all three. So minus 2x plus 4 minus 2 root 3. And then do the last one times all three, negative x root 3 plus 2 root 3 minus root 3 times root 3, which is 3. If you've done it correctly and those are conjugates, the thing should cancel out, right? So if I look at what I have there, I have a positive x root 3 and a negative x root 3, a negative 2 root 3, and a positive 2 root 3. So I get from this x squared minus, there's 1, 2 terms with x, so negative 2 minus 2 is negative 4. And then there's 1, 2 terms with a constant, positive 4 minus 3 is 1. So that was the second set of parentheses, which means I still have to multiply this times the first. So please do this carefully, because if you make a silly mistake in here, you're going to be so mad at yourself. So I distribute the first ones to all three, right? So x times x squared is x to the third minus 4x squared plus x, and then do the 3 times all three. So plus 3x squared minus 12x plus 3, and then combine your like terms. And the last step is show this as an equation by doing f of x. Okay, if you don't do that last step, you are going to lose points, so don't do it. It's an equation. You have to set it up as an equation, which means equals. Questions on that? So just be really careful. It's tedious, but it shouldn't be hard. Okay, so I'm going to come back up to this one. So this is your finding your end behaviors, your zero with multiplicities, y-intercept, and graph. So the first thing you've got to do is take this function and put it in decreasing degree order. So x to the 6th minus 2x to the 4th minus 3x squared. And then look at your end behavior. So highest exponent is even, number on front is positive. These are both up. And then I want to set this equal to 0 and solve it. So I'm going to have to factor it, set it equal to 0. I can actually take out an x squared, and I get x to the 4th minus 2x squared minus 3. So then this set equal to 0. I get x squared equals 0, and then I would get x squared and x squared as factors of x to the 4th, and a negative 3 and a positive 2 are going to give me the, negative 3 and positive 1 are going to give me the negative 2 middle term that I need. So I can set them each equal to 0. And I have a 0 that is 0 with a multiplicity of 2 here. Here I get x equals, well, x squared would equal 3, and x would equal plus and minus the square root of 3, which means I have a root of root 3 and a root of negative 3. Both those multiplicities would be 1. And then here I get x squared equals negative 1, and x would equal the square plus or minus the square root of negative 1, which is not a real number, so I ignore that root. So when I'm listing out my zeros, I would get this should be 0. I get 0 with a multiplicity of 2. I get positive root 3 and negative root 3, both with a multiplicity of 1. The y-intercept I would get by plugging in 0 into all the x's, 0, 0, and 0, and I get 0, 0. So then I go to my graph and plot what I already have. So 0, 0 is in the middle, and then I have positive root 3 and negative root 3. So root 3 is approximately like 1.7, let's say, because it's in between 1 and 4, closer to 4. So I would plot one here and here. I know both my arrows point up, so I know I have something like this. And then I need to know how far down in between this section here we go down. So I'm going to plug in, let's say I'll plug in 1, right? So 1 to the 6th minus 2 times 1 to the 4th minus 3 times 1. 1 minus 2 minus 3, negative 1 minus 3, which is negative 4. So now I know how far down to go. I can also plug it, let me put that on the positive side. I can also plug in a negative 1, or if I look here, because these are all even powers, if I were to plug in a negative x, it would go back to positive x, which tells you that this is symmetric to the y-axis. So I can also go to negative 4 here. So then I would come down, come back up. This is going to bounce here. It's going to come back down, and then it's going to cross through at that root 3. And there's my graph. All right, and then 2, 3. Oh, wait. Okay, then we got to 2, 3, which was the last couple of days. So we did long division. Again, I'll work this out in just a minute, but we did long division. We did synthetic, but you're not going to it's not going to say just divide using synthetic. You're going to use synthetic to find other things like this. Use the remainder theorem in synthetic division to find the value of the function. What do those instructions mean? I'm going to do synthetic with a negative 2, and then do what with it? Do I list the whole quotient? No. What is this asking for?
You have to check it with you plug in the negative 2 into the actual function.
So good. So the answer is just the remainder, right? And a way you can check it is by taking that negative 2 and plugging it back in. So the negative 2 goes on the outside. I don't change the sign because it's not an x plus or minus. It is telling you x is negative 2. I look at my initial function. I'm missing a 0x term, so I add that in. List my coefficients, 3, 1, 0, negative 4, and then synthetic division. And I get negative 24. That is your answer. You can either write it as just negative 24 or f of negative 2 equals negative 24. But do not give me the whole quotient. That's not what you're looking for. Remember, instructions are important. Use the remainder theorem in synthetic division to find the value of the function. I'm just looking for the value of f of negative 2, which is negative 24. And again, you can check the other way, but your work better show synthetic division. Questions on that one? Okay, so we're coming back to the long division one. So you want to make sure that this is in order of decreasing degree. No terms are missing. 2x to the third plus 7x squared plus 4x minus 3. Neither of those are happening. And then this goes on the outside, x squared plus 2x minus 1. Same thing, I would check that to make sure there's no powers missing. So then to get from x squared to first to first, x squared to 2x to the third would be 2x, and I'll multiply that times each term on the outside. So 2x to the third plus 4x squared minus 2x. I'm going to change my signs. I get 3x squared plus 6x. Bring down the minus 3. And then repeat the process. So what do I have to multiply x squared by to get to 3x squared? And that's a positive 3. And I'm going to go to each term. And I get 3x squared plus 6x minus 3. And then I change my signs. This cancels, and this cancels. So my quotient is just 2x plus 3. The remainder would be 0. But if I did have a remainder, I would put the remainder over my divisor and add it to that quotient. Okay, then it says, show that x is a solution of the third degree polynomial equation. Use the result to factor the polynomial completely and list all the real solutions of the equation. What does all that mean?
I have a question on the last one.
So how would you show that x is a solution of the third degree polynomial? And how do I know? I'm going to use synthetic, but then how do I, what am I looking for?
The remainder.
It's good. Remainder should be 0. So I'm going to put 2 on the outside. I'm going to do synthetic. This is the third, the second, the first, so I don't have to add anything in. Bring this down. And I get 0, so that's what should happen. That's the first part. Show that x is a solution of the third degree, so I'm looking for that work. Then the second part says, use the result to factor the polynomial completely. So I rewrite my quotient. And then factor it. Factored completely would be all the way out. List all the real zeros of the equation. Means I get negative 1/2 from here. I get negative 3 from here. And then what else do I have to include? The 2 they originally give you. Somebody's not going to include it. And this is the conversation that you need to know. That is part of all the real solutions, not just what you're finding. Okay. So they gave it to you at the beginning, but it is part of all the real solutions. Okay, so then this is, back to it. I did an extra one example at the bottom too. But this is what you would use your graphing calculator for, okay? Find all the possible roots, then use the graphing calculator to find one root, then find the remaining roots by factoring or using the quadratic formula. So the first thing I'm gonna do is list my possibles. Then I'm gonna plug that function into my graphing calculator. One of those possibles is gonna line up with what you're looking at as your x-axis. I will take that, put it on the outside of my synthetic division, decrease it a degree, and then I'm either going to have to factor what's left or use the quadratic formula because it might not be factorable. I'll review the quadratic formula in a minute too. So this is on the calculator, and again, I'll work through that later. Then use the Descartes rule to find the number of positive and negative real roots. So for Descartes rule, for possible positive roots, I do what? Count the sign changes. And I decrease it by 2 until you hit 0. So if I counted 7 sign changes, let's just say, then it would be 7 or 5 or 3 or 1. And yes, you could see 7 sign changes because you're not actually doing the work here, you're counting. So I don't feel so bad if you have to count to 7, okay? How about for the negative roots? What do you have to do first? Plug in the negative, right? So plug in the negative x, then count the sign changes. And again, you'll subtract 2 until you hit 0. So if I counted 4 sign changes, then it would be 4 or 2 or 0.
This one has no sign changes.
So in the beginning, I didn't plug in a negative, but from the beginning there's 1, 2, 3, 4 sign changes, right?
Yeah. No, for the negative is one though.
Oh, okay. So that's 1, that's 2, that's 3, that's 4. So positive would be 4 or 2 or 0. And then I plug in a negative. This is 4x to the 4th minus, this is a negative and this is negative, so this is plus 3x to the 3rd. This becomes positive, positive 2x squared. A negative turns to negative, that becomes positive and positive. It's positive all the way through, so there are no 0 roots. That would be super helpful if you had to try your possibles, right? That could cut out half your possible bank if it said there was 0 negative roots. Okay, so find all the possible roots. Use the graphing calculator to find one root, then find the remaining roots by factoring or using quadratic formula. So the first thing I do is the possible factors, which is plus and minus. 1 and 18, 2 and 9, 3 and 6, right? So 8, 9, 18. They would all be over 1, so they all simplify back to what they are. So I know these are my possible roots. If there was something other than a 1 at the front, I would put them all over 1 and then all over the other factors of that number. So then I'm going to type this into my graphing calculator. So y equals, let me clear this one out, x to the 3rd minus 2x squared. Is it minus 9? Minus 9x plus 18?
Yes.
Plus 18. Enter. Graph. All right, so this one has, again, nice even roots. I'm running out of examples because there's only so many numbers I can give you. I promise you on the test, they will all not be whole numbers, okay? So what you want to do is identify, you're only going to see one run straight through a tick mark on your test, okay? And so I can either look at it here or I can go to my second table and I can look for the zeros here. So the y would be 0 for me to find my actual zeros. So I'm going to grab that first one, which is negative 3, okay? Didn't hit record. Why am I so dumb? Sorry. Okay, so now I'm going to take that 0, that was negative 3. Again, I had choices this time. It won't be that way. When you take your test, you're only going to have 1 that shows up that you can see. Negative 3 is going to go to the outside, and then I'm going to do 1, negative 2, negative 9, and 18. I'm going to bring down the 1, multiply it, put it in the next column, add it, multiply it, put it in the next column, add it. Multiply it, put it in the next column, and add it. Okay, there's confirmation that that was a root. And then I'm going to take what's left there, which is x squared minus 5x plus 6. And I'm going to factor it. Again, probably a little bit easier than what you're going to see in your test, but not quite as hard as what was on your homework. Okay, so this would be negative 3 and negative 2, and then solve that, and I get 3 and 2. So my 3 roots are the one I found from my graph, which is negative 3, and then positive 2, and then positive 3. So if you get to this point and that is not factorable, then your other option is the quadratic formula, okay, which we're going to review. Okay, so let's say you get to an equation that is quadratic, but it's not factorable, or it is factorable, but you're really bad at factoring, right? Your other option is the quadratic formula. Remember that x equals negative b plus and minus the square root of b squared minus 4ac is your quadratic formula, all over 2a. That's your quadratic formula. So this is your A is 3, this is your B is negative 2, this is your C is negative 4. And then you just plug it in. So the opposite of negative 2 would be 2 plus and minus the square root of negative 2 squared minus 4 times A times negative C all over 2 times A. You could get one that's not factorable. I mean, there's only so many options I can get. But yeah, you could get one that's not factorable. Or maybe you're better at this than you are at factoring, which can happen too. So 4, this is negative 12 times a negative 4, which is positive 48, over 6 I get 2 plus n minus the square root of 52 over 6. 52 is 2 and 26, which is 2 and 13. This is 2 plus and minus 2 root 13 over 6. And I can simplify that once more because they're all divisible by 2. 1 plus and minus root 13 over 3. So individual roots, that would be 1/3 plus root 13 over 3, and 1/3 minus root 13 over 3. So if I was to list the individual roots, that's what they would be. If you're just giving me the roots, you can leave it like that, that's fine. If it was a square root that is able to be simplified, then obviously you need to simplify it.
What'd you get 48?
Because 4 times 3 is negative 12, and then negative 12 times negative 4 is positive 48.
Oh, okay. Isn't it negative 12 times negative 2? I mean, yeah.
C is negative 4. 4 times A times C.
It's AC.
Yeah. All right, so the calculator portion is the one I had already mentioned, right, where you have to find the root. And then you're going to get something like one of these. So we worked through the height of the projection in class. This is an example we did in class. This is taking your quadratics and applying it to real world situations. You're going to see something like this. I'm not going to tell you exactly what the word problem's going to be, but it's going to be something like this, where you have to set up a quadratic and then answer questions based on it. Whether it be the maximum height, or it be where it hits the ground, or it be when it hits the ground, or when it hits its height. So this is where you're going to have to really kind of read and think through what it's saying. So in that first example, which we did on the notes, right, we graphed it, and then it said how high is the football when it's punted. That's when your x was at 0. We gave the y-intercept. And then C, what's the maximum height of the football? That was the k, right? So that's the max, and that's the y coordinate of it. D, how far from the punter does the football strike the ground? That was this x over here when it came back down. So there's going to be some sort of application on top of something that you're going to have to graph using your graphing calculator, okay? 66 says the path of a diver is approximated by y equals negative 4/9 x squared plus 24/9 x plus 12, where y is the height in feet and x is the horizontal distance in feet from the end of the diving board. What's the maximum height of the diver? And then verify your answer using graphing utility. So something like this you can even do without the graphing utility, but I am going to, the numbers are going to be funky enough that I'm going to give you the graphing utility to find it, right? So you have to think about what it's asking. So what is the maximum height? What is that on a graph?
Your K value.
The K value for the vertex. So if I just simply found the max here, whatever this point is, this HK, then this answer is just the K value, okay? Don't overthink these. These should be easy. It's just that it's words and you freak out. What if I asked how many feet away from the board does he hit his max? Now what are you looking for?
Yeah.
The x coordinate of your vertex. Does that make sense? So if I'm asking how far from the board does he hit the max? Okay, how far from the board would be this distance here, and I would know this because this is the h. That's the x coordinate of your vertex. Does that make sense? Yeah? So you've got to be able to apply things like that.
Wait, like how far the distance between the x and the vertex, or what?
No, like how far from the board could be like what's the horizontal distance? Let's just say maybe the wording would be what's the horizontal distance from the board to where he hits his maximum, and that's going to be the h, right? The x coordinate of your vertex. So you're going to see, again, you're going to see word problems that are dealing with quadratics. Using your calculator, you're going to have to decipher information. Okay, it could involve the zeros, it could involve the max, it could involve the max h or the max k, something like that. Okay, so in this last example, it says find the possible roots, then use the graphing calculator to find one actual root. Use synthetic and the root found to reduce the polynomial a degree, and then find that should say find the roots. So my possible roots are going to come from plus and minus the factors of 3, which are 1 and 3, and the factors of 32, which are 1 and 32, 2 and 16, 4 and 8, which means 1 goes over all those, 1/2, 1, 1/4, 1/8, 1/16, and 1/32. And then 3 goes over all those. So 3 over 1, 3 over 2, 3 over 4, 3 over 8, 3 over 16, and 3 over 32. So those are all your possibles. Then I'm going to plug that into the graphing calculator. So I've graphed it just using the app this time, and you can see that it crosses through somewhere between these. Each tick mark here is 1, 2, 3, 4, 5. So that just from 0 to 5 to -1 is divided 5 times, which means this is definitely not a whole number here. That's not a whole number there, but this is 1, 0. And again, you'd get that from your table value as well. That tells me one of the zeros is 1. So then I would put 1 on the outside, 32, -52, 17, 3. So I've got my third, my second, my first, and my constant. And then I'd bring down the 32, multiply it, put it in the next column, -20, -20, -3, -3, and 0. So now I've got down 1, 0, and reduce this a degree, 32x squared minus 20x minus 3. So then I want to see if I could factor this. I'd probably multiply this by 32 times -3. And I get -96. Factors of -96 that sum to 20. So I get, like, obviously 1 and 96. I get 3 and 32. That's not going to work. I get 4 and 24. And that's one that if I make one positive, one negative, it's going to give me that -20. So I need the bigger to be negative, so I'm going to use -24. So I get 32x squared plus 4x minus 24x minus 3. And I'm going to factor this by grouping. From the left side, I take out my 4x, and I get 8x plus 1. From the right side, I take out my -3, and I get 8x plus 1. So 8x plus 1 and 4x minus 3 gives me my remaining roots of -1/8 and 3/4. So when I go to add those in, 0 being 1, -1/8, and 3/4.